1. The principal of the college, Dr. Devdas, today's chief guest, Dr. Megha Uplani madam, all heads of the department, the coordinators, the teachers, and all the teachers and students who participated remotely from various states for this workshop. All are cordially welcome. In today's competitive world, it is important to pass the sacred examination not only to get into the teaching profession but also to enter into the research. After passing the JRF examination, one can get admission in a reputed research institute. For the same reason, many students are preparing for the next set examinations. In fact, it is not difficult to pass the exam if the study is planned properly. The Marathwada Vikramandal College of Commerce, Deccan, Pune, Maharashtra, has organized a 2-day workshop to guide the students and prepare them to face the exam successfully. In this 2 days workshop, we will try to touch on all the elements in paper 1. We will have session of highly experienced experts. They will guide us in the right direction. On behalf of the college, organizing committee, and all the students, I would like to express my heartfelt thanks to all the resource persons, Dr. Megha Uplani madam, Dr. B.N. Mapari sir, Dr. B. Tamkir sir, Dr. C.R. Das, Professor Shashank Surve, and Professor Praveen sir for this acceptance of our invitation. Once again, I welcome you all and wish you all the best for the workshop. Thank you.
Thank you, sir. This workshop is going to be very informative as the academic is very exciting. I sincerely hope that this workshop will be fruitful
I I remember when UGC introduced this particular concept of essay as a qualifying exam, there were mixed opinions all across the country. There were different school of thoughts that emerged there, and then some of them were of the opinion that how can a small test be a testimony of somebody's knowledge? And there was another school of thought which also believed that there was another school of thought which believed that if there is kind of a qualifying exam for every profession, why not for academics as well? So this mixed thought evolved, and we have seen a lot of ups and downs in this journey from 1995 to what we are today. Today, let's accept this fact that it remains a qualifying exam for the academic institution who wants to make a career as a professor, teacher. So, with this context, there is a kind of a fear and apprehension and what this test is about, how is it, in what way it is evaluated, what preparation needs to be done, how is it different from a regular exam that we do. So with this kind of applications, people do give a half-hearted efforts at times, or they are not completely informed so as to be well prepared for this kind of test. So, keeping all of those applications in concern and uh, the various aspirants, today they wish to take up this particular exam. We thought of having a small workshop on this. Uh, I said, let's not call this the faculty development program. This is not a faculty development program because this is, we are just guiding some of our aspirants from the ones who had already qualified this exam. And some of us are already there as a part of this particular design of this particular test. So in this particular background, we thought of having this workshop. So I really appreciate as well as acknowledge all the speakers who have agreed to be the resource person for this workshop video here, and also congratulate the organizers for this, and more importantly, wish the participants a very good luck. Thank you so
Thank you so much for guiding us and for tackling every single effort in the direction of improving educational skills. Now, I would like to request our chief guest and
for all of you. When principal sir was talking with you all regarding set examinations, I went back in 1997-98 when I was on that side. I was trying for clearing my set in education. Friends, that time we were facing different kind of examination pattern, no any kind of orientation sessions, this kind of workshops, or even questions papers were not available. So we attempted examination once for knowing the structure of questions because we were not able to get any kind of trace about nature of questions. काहीच समोर नसायचं सेटची परीक्षा म्हणजे अंधारामध्ये बाण मारायचे अशी परिस्थिती होती कारण एवढं चिठोरी सुद्धा तुम्हाला काही मिळायचं नाही प्रश्न आधी बघायला एखादी परीक्षा द्यायची आणि मग दुसरी परीक्षा तयारी करून द्यायची. That way, I cleared my set in education in 1998. We wrote a question for one question for 40 marks, descriptive type of examination. And now the whole nature of examination has been changed. But one thing is common when set has been started, that is paper one. The nature of paper one, components of paper one, and almost what can I say? The difficulty level of questions is same from the very first set examination which was conducted in 1925. Friends, you college have planned uh, this kind of very will result in very fruitful effect. This kind of workshop is very what can I say uh, grand great initiative for all of you. And as Sandeep sir has already told you that today and tomorrow you will be having sessions for all the components of paper one, right? So now I will come to the point which is given to me. It is I think this is chapter 2 in your set paper 1 syllabus, that is research aptitude. So very important thing is now I will tell you few points which you should study in detail on your own or with your friends in discussions. But it is not possible to cover everything in this hour or hour and half an hour session. So I would like to tell you what are the points to be studied for this particular topic. The very first thing you should know the difference between attitude and aptitude. Now, if you look at the screen, research can be seen from three different perspectives. People conduct research for degrees like MPhil and PhD in their own subject or own discipline. लोक आपल्या आपल्या इंटरेस्टनी आपल्याला PhD किंवा MPhil पाहिजे म्हणून रिसर्च करतात. Few teachers or few people conduct researches for grants, that is research funding from various funding organizations or institutions. Of course, they are also in their own subject, or if we consider today's situation situation, that is when we are talking and thinking about implementation of new National Education Policy 2020 interdisciplinary also. And another thing is the teachers conduct researches for better teaching learning process. And this is the reason why this unit has been added in state syllabus. Many of students have already asked me through the years, कशाला आले हा टॉपिक? आम्हाला मला कॉमर्सचं टीचर व्हायचंय, मला इकॉनॉमिक्सचं टीचर व्हायचंय. Why should I study this topic, that is research aptitude? Because irrespective of your subject, irrespective of your discipline, you need to be a researcher for your own subject for better teaching learning process if you wish to be in the profession of teaching. चांगलं शिक्षक व्हायचं असेल तर तुम्हाला रिसर्च बद्दल काही ना थोडी गोष्ट माहीत असलीच पाहिजे. रिसर्च प्लॅन कसा करायचा, कंडक्ट कसा करायचा आणि त्याचं डॉक्युमेंटेशन कसं करायचं हे प्रत्येकाला माहीत असलं पाहिजे. दॅट इज वाय द टॉपिक रिसर्च ॲप्टिट्यूड हॅज बीन इन्क्लुडेड इन द सिलेबस. क्लिअर? डिफिकल्टी मला लिहिलेली का आहे हा टॉपिक? So this is the reason why it has been included in the state syllabus. Now, as discussed in the previous slide, action research. Action research means study and enhancement of one's own practice. Practice as teacher. And teachers view as researcher or critical inquiries of their own practice. Got the point? समजलं सगळ्यांना? And one very important message I would like to share with you is learning to teach is a lifelong endeavor, and this needs research. Friends, you know that there are many ways and means of solving problems. There are problems in our lives. Many kinds of problems are there, and we are trying to solve with whatever we feel correct, we feel possible. There are many methods of solving problems, but research is a method which helps us in problem solving systematically, because research is a way of thinking. Research is a method of thinking, and everyone should know how to think critically, how to think in a proper way, logical way, and that's why research is included, research aptitude is included in our set syllabus as compulsory component of paper 1, which is research aptitude. If you would like to become teacher or educator, who is strong educator? Strong educator is who knows this interactive cycle in detailed way, in a critical way we can say. And this interactive cycle starts from questions. As already said, आताच म्हटलं तसं की problems खूप आहेत आपल्याजवळ. So every research starts with question or questions, and then after observations and reflections, there is a list of many possible alternative solutions to this that particular problem. Then, as teacher, as researcher, we have to identify most probable answer to the problem, and we have to implement that probable answer. And if the problem is solved, no problem, go ahead. And if it is not solved, then solution, and that's why the term cycle is written over here. Cycle का आहे because the process goes continue till problem gets solved. And एकदा हा प्रॉब्लेम संपला तर सुटला तर संपला असं नव्हे, एक संपतो की तो दुसरा सुरू होतो. सेम इज द केस विथ research also, and therefore research is ongoing cycle. Both the terms are very important, ongoing and cycle. So this nature of research is very important. And another sentence which I would like to share with you all is, good teachers are good researchers. Very important. Good teachers are good researchers. If they were not, they would not be good teachers. आता गुड रिसर्चर व्हायचं असेल गुड टीचर होण्यासाठी तर काय काय आलं पाहिजे, आकाशी सांगितलं तसं रिसर्च प्लॅन करता आला पाहिजे, ऍडमिनिस्टर करता आला पाहिजे, म्हणजे इम्प्लिमेंट करता आला पाहिजे, आणि त्याचं डॉक्युमेंटेशन करता आलं पाहिजे. सो ऑल दीज फेजेस आर inseparable parts of every teacher's life. That is very important. Now coming to the unit 2, that is research aptitude. There are 6 sub-points. First sub-unit deals with meaning, types and characteristics, positivism and post-positivist approach to research. हे जसंच्या तसं तुमच्या सेट सिलेबस मधलं आहे, सिलेबस मधलं पॉइंट आहे का? So we will go by point to point. Research is knowledge acquisition through reasoning, through intuition, but most importantly, through the use of appropriate methods, which are called as scientific method. So we should know that what is scientific method. Scientific method involves 7 important steps. And these are the steps which I would like to recall you for all of you, that we all, I mean you all have studied in your 6th standard science textbook. Do you remember? आठवते? या जरी तुम्ही मराठीतून शिकला असाल तर शास्त्रीय विचार पद्धतीच्या पायऱ्या म्हणून 6वीच्या सायन्सच्या टेक्स्टबुक मध्ये आपल्याला शिकवलेल्या आहेत. ठीक आहे? इंग्रजी असेल तर सेमच टायटल असेल, नो प्रॉब्लेम. सो सायंटिफिक मेथड स्टार्ट्स विथ research question or any problem in front of us. Identify a hypothesis related to the question. Hypothesis means probable hypothesis. If result supports your hypothesis, problem is solved. If it is not supported by the results, hypothesis is not supported by the results, then review your hypothesis and start with second probable solution to solve that particular problem. There are 5 steps which we have already discussed. Now, basic elements of scientific method. I will not discuss all these terms in detail, but I would like to tell you that you please note down what is empiricism, what is determinism, and what is skepticism. These are the terms of scientific method. Now we will go through some definitions of research. You can see here, research is a systematic process of collecting and analyzing information for some purpose. Very important. It is a systematic process. Look at the terms which are written in different colors. These are the characteristics of research process. So it is a systematic process. It includes data collection, it includes data analysis, and also all these things are to be conducted for some purpose. And the purpose of every research is to solve problem. It may be academic or it may be research problem. So another definition also, research is a systematic, controlled, empirical, that's why the term empiricism, empirical, amoral, public, and critical investigation. So these are the characteristics, very important, we have to keep in mind. Then it is natural phenomena guided by theory and hypothesis about presumed relations among such phenomena. So these are few of definitions. Now, meaning of paradigm. What is paradigm? Because this is one point we included in your syllabus. Paradigm are way of organizing information so that fundamental abstract relationships can be clearly understood. Major paradigms of research in social sciences. Even if you are from commerce discipline or somebody may be from science discipline, when you will be entering in your classrooms as teachers, you are from social science. And that's why it is required to know what are major paradigms of research in social sciences. First is positivist paradigm, post-positivist paradigm. These are the terms included in your syllabus. Then interpretive or constructivist paradigm, participatory, transformative or advocacy paradigm, and pragmatic paradigm. Now, with this kind of comparison, we will see the clear-cut difference between all these 5 paradigms which we have considered in social science. If we consider positivist paradigm, look at the approach, it is quantitative. याचा अर्थ आहे जर तुम्ही पॉझिटिव्हिस्ट अप्रोचनी रिसर्च करायला घेतला तर तुमचा जो डेटा कलेक्शनचं नेचर असतं ते क्वांटिटेटिव्ह असतं and methods are correlational research, causal comparative, experimental or cost analysis, etc. If the research paradigm is post-positivist, then the approach will be qualitative, but writing report of research with a structure that resembles the quantitative research. So the main difference between positivist and post-positivist research paradigm is in positivist research, the data collected in the research process is of quantitative nature, while in post positivist, it is in qualitative nature, means the nature of data is in terms of words. Descriptions are there, and of course, exploratory surveys are to be conducted for post-positivist research paradigm. When we consider interpretive or constructivist paradigm, then obviously, when we are talking about constructivist paradigm, qualitative data will be involved and the methods. So when we are talking about interpretive or constructivist paradigm of research, the methods involved are grounded theory designs, narrative research. It is not possible to explain all these things in this particular time interval, but these are the terms you can explore afterwards. Phenomenological studies, ethnography, ethnomethodology, case studies, evaluation researches, policy researches. These are the examples or methods. When we talk about participatory or transformative paradigm of research, it includes mixed methods. Mixed means some part will be qualitative and some will be quantitative. And there are number of designs of these mixed methods. First qualitative, then quantitative, first quantitative, then qualitative, or simultaneous, or embedded designs of qualitative and quantitative, depending upon inquiry of your research. This is and the method is action research. So we teachers will be strongly connected throughout our career and life will be with action research, that is involve, that is, some part is qualitative and some will be quantitative. Now, this diagram will make it clear the difference between positivism and constructivism. So, red columns make it clear that quantitative and qualitative. So positivism is related with qualitative, quantitative. That is what we have seen in previous slide, and now you can see here in positivism, positivist paradigm of research, only one truth, one reality. The characteristic of positivist paradigm is single reality. एकच reality साठी काम केलं जातं. On the contrary, in qualitative paradigm, multiple realities may occur as an outcome of our research. Objectivity is there, where it is characterized by subjectivity. Numerical data and textual data in terms of words. And here, context is also very importantly considered. In positivism, closed-ended questions are asked, yes no questions, or forced choice. Four options will be given, five options will be given, and respondent will be forced to choose the one. Even if sixth option is his or her answer, there is no provision which is given in this kind of paradigm. So this is the major difference. Findings, causal relationships can be explored, and understanding of phenomena. And that's why again we can highlight the characteristic of constructivism, that is qualitative paradigm of research, is it can come out with multiple realities. So this is a major difference between these two. Now the second sub point, I hope this is clear to you all, and you have noted number of terms which I wish you explore afterwards. Second sub-point is methods of research. Obviously, not methods of research in science or physics or chemistry or commerce. These are methods of research in social science, because all teachers will conduct their researches as social science researchers, and that's why you all are required to know these methods of research, namely experimental, descriptive, and historical, qualitative and quantitative methods. Most part of qualitative and quantitative is already discussed in the previous point, so we will consider with methods of research. So first, historical method of research. As name indicates, it is related to study of historical events. So scientific method of inquiry of historical problems. It also starts with selecting the problem, formulation of hypothesis, and collection of data. So you can easily identify that all researches have same set of steps or stages which with research problem, selection of research problem, then hypothesis framing, then data collection, then data analysis, and then conclusions of the research. But all methods differ at the stage of data collection depending upon nature of their research inquiry. Now, as the historical researches are focused to study historical problems, now history means not only Dhal and Talwar. History means मराठवाडा मित्रमंडळाच्या स्थापनेपासून जे अल्युमिनाय बाहेर गेलेले आहेत त्यांच्या प्रगतीचा अभ्यास करणे ही हिस्टॉरिकल स्टडी. Getting me? So this kind of historical events can be studied using historical method of research. Now, the characteristic, a very important thing which we should keep in mind is in history it is not possible to observe events, to take observations because event is already happened. होऊन गेलंय ते सगळं. आता आपल्याला परत करून बघता येणार आहे का? नाही. And that's why we have to rely as researcher on primary and secondary sources of information. Now, primary sources include weapons, clothing, building, painting, coins, then records, and secondary includes reports of the institutions, persons, testimonials, and write-ups kept by actual witnesses. So question will be asked as some options will be from that list and one option from this list, and you will be asked which is secondary data source or data pool. So that kind of questions can be posed for you as set aspirants. Then remaining part of historical research is when direct observation is not possible, historical criticism, and therefore when we take historical research, this part, that is criticism part, is very crucial and critical in historical research. It has two parts, two levels. First one is external criticism, validity of documents. म्हणजे 1000 वर्षापूर्वीचं डॉक्युमेंट तसंच दिसतं जसं आत्ताचा कागद जर गाईच्या किंवा म्हशीच्या शेणामध्ये काही तास फुटून वाढवला तर. सो वरवर दिसतात की दोन्ही कागद एकसारखेच दिसतील पण त्याची व्हॅलिडिटी तपासणं गरजेचं असतं. आणि काही गोष्टी अशा असतात की त्याच्यासाठी इंटरनल क्रिटिसिझम पण गरजेचं असतं. एखादा कागद 1000 वर्षापूर्वीचा आहे किंवा एखादी वस्तू 1000 वर्षापूर्वीची आहे तर त्याच्यासाठी सुद्धा जी उपलब्ध आहे प्रणाली, कार्बन डेटिंग सारखी प्रणाली जी उपलब्ध आहे ती वापरून आपल्याला त्याचं लाईफ निश्चित करता येऊ शकतं. तेव्हा या सगळ्या गोष्टी लक्षात घेऊन व्हॅलिड डेटा कलेक्ट केला जातो. then it will be analyzed and researcher will come to the conclusions and obviously interpretation of data and writing research report. Now come to the descriptive researches. Description and interpretation of existing conditions, practices, beliefs, attitudes, traits. हे तर तुमचं उद्दिष्ट असेल हे करायचं आहे तर डिस्क्रिप्टिव्ह रिसर्चेस करावे. तेव्हा असे प्रश्न येऊ शकतात की हे करायचं आहे तर कोणती पद्धती वापरावी. रिसर्च इज एम टू आयडेंटिफाय पॅटर्न ऑफ current beliefs about ... which will be proper method of research. असं टॉपिक देऊन पण तुम्हाला मेथड विचारू शकतात, तेव्हा या गोष्टी तुम्ही समजावून घ्या. Steps are always same as the selecting problem, formulation of hypothesis, the data collection using various tools and techniques such as questionnaire, opinionaire, schedules, interviews, their observations. Now, in this list, questionnaire, opinionaire, schedule are research data collection tools, and interviews and observations are techniques. So, question may come as which of which of the following is technique of data collection. Got the point? So, for that, you should know these things. Then, fourth point, which is important related to descriptive research, is evaluation criteria. What exists at present and how does it help in improvement? So, for status studies, सद्यस्थितीचा अभ्यास करण्यासाठी descriptive researches mostly घेतले जातात. Interpretation of data. जेव्हा डेटा इंटरप्रिट केला जातो तेव्हा पर्सनल इंटरप्रिटेशन इज ऑल्सो इम्पॉर्टंट, बट इट इज सब्जेक्टिव्ह. फॅक्च्युअल इंटरप्रिटेशन कधी करायचं? इट इज सायंटिफिक अँड ऑब्जेक्टिव्ह. डेटा ट्रँग्युलेशनसाठी म्हणजे दोन वेगवेगळ्या तीन वेगवेगळ्या सोर्सेस कडून माहिती क्रॉस चेक करायची असेल तेव्हा. Comparative interpretation, data compared with external criteria, scientific and objective, and then research report writing. Then surveys are to be conducted. That this by part we have calculated in descriptive research. Now in today's context, when we are facing some different situation because of COVID-19, data collection tools and techniques have also been shifted from questionnaires, opinionaires, and they have taken online form. So we all are using Google Doc and other facilities, that is video conferencing also used for data collection. Telephonic data collection is also possible when it is required. Now, experimental research. When experimental researches are to be conducted, when we are required to guess about what will be happen. If this is to be if this is done, what will be its effect? So cause and effect studies are experimental researches. So selecting the problem, finding variables is very important in every research. So what is research? Research is study of variables, and in experimental researches, variables, you should know which is your independent variable and which is your dependent variable. तुम्ही कशाचा परिणाम कशावरती झाला हे बघणार आहात. So कशाचा is independent and कशावर is dependent variable. For example, if I prepare or develop the computer assisted instruction package for learning geometry, then that CAI package will be my independent variable. That is, method of instruction is my independent variable, and achievement, academic achievement score, किती मार्क मिळाले त्या geometryच्या पेपर मध्ये, will be dependent variable. So in experimental research, researchers should know which one is independent variable and which one is dependent variable, and which are the variables which he or she needs to control to get better results, which can be applied everywhere. Generalization is possible. So next will be formulation of hypothesis. as already we have seen, then administration of independent variable, data collection, analysis, and acceptance of rejection of hypothesis. That will be statistical process, and then generalization is possible of the results of your experiment. These are types of experiments: laboratory experiments, field experiments, and natural experiments. Now, if you look at the points of comparison for teachers to conduct experiments in his or her classroom, it is not possible to go for laboratory experiment criteria or even for natural experiment criteria. We have to look for field experiments, that is our classrooms or sports grounds or our laboratories where students are performing, and therefore hardly we can control few of the variables because we are working with human beings, and it is not possible to prepare exactly similar or equal groups. मुलांचे दोन सारखे गट तयार करणं शक्य आहे का? Come on, झोपू नका. एका वर्गातल्या विद्यार्थ्यांचे दोन समान गट करणं शक्य आहे का? इन सम वे शक्य आहे. हाईट, IQ मोजू शकतो आपण, दोन गटात विभागू शकतो. देन सोशिओ इकॉनॉमिक स्टेटस चेक करून आपण दोन गटांमध्ये करू शकतो, नाही का? म्हणजे त्यांना सगळ्याच फॅसिलिटीज घरी मिळालेल्या असतात म्हणून. But it is not possible to divide our classroom exactly similar to in exactly similar to groups because everyone has carried out a different gene pool. Getting me? आपला सगळ्यांचा gene pool इतका वेगळा आहे, आयडेंटिकल आहे, म्हणजे तो आपल्याशी फक्त आयडेंटिकल असतो, दुसरा माणूस आपल्यासारखा नाही आहे. आहे का मग एक्झॅक्टली इक्वल? प्रयोगच नाही करायचे का? मग करायचे का नाही प्रयोग? करायचे. मग कसे करायचे? तर मॅक्सिमम पॉसिबल व्हेरिएबल्स कंट्रोल करून करायचे, आणि जे कंट्रोल करता येत नाही ते आपल्या लिमिटेशन मध्ये लिहून टाकायचं. क्लिअर? एक्सपेरिमेंटचे वेगवेगळे डिझाईन्स आहेत. True experimental design, which is highly difficult for our classrooms, but we can have pre-experimental and quasi-experimental designs. Correlational studies also can be conducted. It is not possible to explain these designs in this time interval, so you please note down these designs and you study its characteristics and what are the components involved. Third subunit is steps of research. So we have already considered these steps of research: identification of research problem, review of related literature, hypothesis framing, sample and sampling, data collection, data analysis, finding of research and conclusion. When we look at this block diagram, it is very easy. But the actual procedure involves so many other things also. So this is the detailed format of previous diagram. So if you can see here, the review of related literature is is connected with problem as well as hypothesis framing as well as data collection and data analysis also. And after getting findings of the research, again we have to check with hypothesis framed in the beginning, and also we have to check with directly related researches for discussion before coming to the final conclusion of the research. That is very important. मगाशीपासून आपण बघतोय की रिसर्च प्रॉब्लेम्स घ्यायचे कुठून. सगळं काही सुरू होतंय कुठून? रिसर्च प्रॉब्लेम पासून मिळतात. रिसर्च प्रॉब्लेम्स मिळतात कुठे? रिसर्च प्रॉब्लेम्स येतात आपल्या अनुभवातून. When you become teacher, you will face that, you will feel that these are the points where some research is required. If I am physics teacher and if I am teaching magnetism, topic magnetism to my ninth class students, then I can conduct experiment as four groups can be, three groups can be prepared considering all controlled variables. One group will be taught by regular lecture method, one by demonstration method, and one by direct laboratory experience method. And then their performance will be analyzed by considering post test, and then I can come to the conclusion that this is a method which is very useful in teaching topic magnetism to ninth class students. What the point? So these are the possibilities where we can get research problems and individual experience. आणि सगळे एक्सपिरियन्स आपल्यालाच येतील का? नाही, कधी कधी आपण दुसऱ्यांच्या एक्सपिरियन्सेस वरती पण भरोसा करतोच की कसल्या कसल्या सायनाइड खाल्ल्यावर मरतं, सायनाइड खाल्ल्यावर माणूस मरतं. गेलाय की नाही आपण भरोसा? आपण कुठे पाहतो? हा, तसं आपण दुसऱ्यांच्या सुद्धा अनुभवावरती विश्वास करतो. तसं interaction with others, experts in the field, senior teachers, alumni, शिकून गेलेले विद्यार्थी जास्त धीटपणे आपल्याला सांगतात कुठल्या कुठल्या गोष्टी अजून कडक सुधारणा पाहिजे. तर याचा alumni बरोबरचं open discussion is also a very nice relaxation for every teacher, and that can open many research areas for us as teachers. Review of earlier research studies, journals madhun, seminars madhun, conferences madhun. There are a number of research topics which can call us for undertaking those researches. So variables we have studied. We will not explore this. This is a combination of variables. When two or more quantitative variables are there, correlational research is useful. Quantitative means ज्यांचं मोजमाप आपण अंकांमध्ये करतो. development of CAI package and its effectiveness. CAI package हे कॅटेगोरिकल आहे, म्हणजे शब्दामध्ये सांगावं लागतं, आणि अकॅडमिक अचिव्हमेंट हे अंकामध्ये येणार आहे. सो एक्सपेरिमेंटल रिसर्च. आणि 2 or more categorical variables, जर क्वांटिटेटिव्ह असतील तर कोरिलेशनल, आणि क्वालिटेटिव्ह असतील तर डिस्क्रिप्टिव्ह रिसर्च. फॉर एक्झाम्पल, social and educational contribution of Rajarshi Shahu Maharaj. Social contribution is one categorical variable, and educational contribution is another variable which is of categorical nature. So 2 categorical variables are involved. That's why descriptive research will be conducted. Okay. There are different data gathering tools. क्वेश्चनेअर, ज्याला मराठीत प्रश्नावली म्हणतात. सायकोमेट्रिक टूल्स म्हणजे सायकोलॉजिकल टेस्ट असतात, जसे इंटेलिजन्स मेजरमेंट, पर्सनॅलिटी, क्रिएटिव्हिटी, इंटरेस्ट, नंबर ऑफ व्हेरिएबल्स आहेत. इंटरव्ह्यूज आणि ऑब्झर्वेशन्स. मगाशी सांगितलं तसं इंटरव्ह्यूज आणि ऑब्झर्वेशन्स हे टेक्निक्स आहेत, तंत्र मराठीत म्हणतात त्याला. आणि टूल्स म्हणजे साधन.
तंत्र सुद्धा साधनच लागतं. कसं ते बघा, इंटरव्ह्यू घेण्यासाठी यादी करणार प्रश्नांची, दॅट विल बी युअर टूल फॉर टेक्निक. सो इंटरव्ह्यू स्केड्यूल विल बी टूल अँड इंटरव्ह्यू विल बी टेक्निक. ऑब्झर्वेशन स्केड्यूल, ऑब्झर्व करणार तर काय करायचं ह्याची यादी केलेली असणार ना. फॉर एक्झाम्पल, आय एम रिसर्चर अँड आय एम supposed to conduct a research on physical facilities in Pune municipal school corporation schools. असं मला अभ्यास करायचा आहे. तर प्रत्येक शाळेत त्याच गोष्टी बघणार की वेगवेगळ्या बघणार? नाहीतर कंपॅरिझन करता येईल का? नाही. सो दॅट लिस्ट विल बी ऑब्झर्वेशन स्केड्यूल. सगळीकडे जाऊन तेच बघायचं. पाण्याची टाकी कुठे आहे, किती तारखेला साफ केली जाते, कळलं ना? किंवा बाक किती आहेत, 2 बाकांमध्ये जागा किती आहे. सेम थिंग्स विल बी ऑब्झर्व युजिंग दॅट ऑब्झर्वेशन स्केड्यूल. गॉट द पॉइंट? क्वेश्चनेअर तयार करताना कोणत्या काळज्या घ्याव्यात? सुरुवातीला बॅकग्राऊंड विचारावी, म्हणजे रॅपो डेव्हलपमेंटसाठी. कोणाला तरी जाऊन डायरेक्ट प्रश्नच नाही विचारायचे. रॅपो डेव्हलपमेंट, त्याच्यासाठी डेमोग्राफिक इन्फॉर्मेशन घ्यायची, तुमचे एक्सपिरियन्स किती, तुमचं म्हणजे मोठी डिग्री कोणती आहे सगळ्यात, तुमची शेवटची डिग्री. त्यानंतर बिहेवियरल रिपोर्ट्स असतील तर काय, ऍटिट्यूड आणि ओपिनियन विचारायचं असेल तर रेटिंग वाले स्टेटमेंट्स विचारायचे. फोर्स चॉईस डिझाईन पण आपल्याला करता येतं, म्हणजे 4 पर्याय द्यायचे आणि आपणच 4 पर्याय द्यायचे आणि सिलेक्ट 1, असं सुद्धा करता येऊ शकतं आपल्याला. जे डेटा अनालिसिसला सोपं असतं, बट सिंगल रियालिटीसाठीच फक्त फायदा होतो, मल्टिपल रियालिटीज येत नाहीत. when you will be going for data collection, take with you explanatory note. का करताय हा रिसर्च? And give confidence that the data given by you will be kept confidential and used for only research purposes. So that kind of note should be there. Length of questionnaire आपण भरून बघायची, म्हणजे कळतं की किती वेळात कंटाळा येतोय, तेवढेच प्रश्नांची लांबी. क्वेश्चन्सची ऑर्डर इझी टू डिफिकल्ट, क्वेश्चनची डेन्सिटी, या सगळ्या गोष्टी आपण लक्षात घेतल्या पाहिजेत. सायकोमेट्रिक टेस्ट निवडताना कोणत्या बाबी लक्षात घ्यायच्या? इफिशियन्सी, ऑब्जेक्टिव्हिटी, त्यानंतर डिस्क्रिमिनेशन, रिलायबिलिटी. These are the terms which are already studied by that test developer. You are required as researcher only to consider these things for comparison of the tests available in the market. समजा मला पर्सनॅलिटी टेस्टिंग करायचं आहे, तर मला आधी मार्केट सर्वे करावा लागेल की पर्सनॅलिटी टेस्टिंग करणाऱ्या आता मार्केटमध्ये किती टेस्ट उपलब्ध आहेत. समजा 4 आहेत, मला 4 मिळाल्या, So those four will have to be studied considering these points, and then one will be selected with proper justification for further research. इंटरव्ह्यूज बद्दल आपण बोललो. सॉरी. Now the next point is report writing and dissemination of research outcomes. म्हणजे आपण रिसर्च प्रोसिजर पासून बघितलं, डेफिनेशन पासून, मग टूल्स टेक्निक्स बघितले, डेटा कलेक्शन बघितलं, आणि रिपोर्ट रायटिंगच्या फेजला आपण आता येतोय. रिपोर्ट रायटिंग का करायचं, तर रिपोर्ट रायटिंग मुळे काय होतं की रिसर्च मध्ये काय घडलं, काय मिळालं हे लोकांना कळतं. टू डिसिमिनेट दोज रिझल्ट्स, रिसर्च आउटकम्स, रिपोर्ट रायटिंग इज इम्पॉर्टंट. सो रिसर्च पेपर रायटिंग अँड रिपोर्टिंग का करायचं आहे आपण आता बघितलं. डिसिमिनेट न्यू डिस्कवरीज, इनिशिएट फर्दर रिसर्च, ऑर्गनाइज वन्स आयडियाज, पब्लिसाइज अमंग पियर्स, career requirement, prestige and credit. So these are the reasons why research outcomes are to be disseminated in the society. मग 3-4 असे देतील, एक नसलेली गोष्ट देतील, आणि असा सुद्धा प्रश्न तुम्हाला अशा प्रकारचे सुद्धा फ्रेम करता येऊ शकतात, किंवा विच इज नॉट नी येऊ शकतात. दिस इज अ स्ट्रक्चर ऑफ रिसर्च पेपर. Title, very important part of the research paper is title or research report even. It should be appropriate, precise, indicating relation between involved variables. Title मध्येच दिसलं पाहिजे ते, and must include mention of population. कोणावरती ते जनरलाइज केलेलं आहे. ऑथरची इन्फॉर्मेशन, ऑथर्स एफिलिएशन, ऍब्स्ट्रॅक्ट 5-6 ओळींमध्ये, कीवर्ड्स. सो याच्यावरून कसा प्रश्न येऊ शकतो, तर दीज आर कंपोनेंट्स ऑफ रिसर्च पेपर. एखादा नसेल, ठीक आहे, ऍब्स्ट्रॅक्ट कसं लिहावं, ऍब्स्ट्रॅक्ट मध्ये काय असतं, ऍब्स्ट्रॅक्टला वर्ड लिमिट असतं, 50 शब्दात लिहा, 100 शब्दात लिहा, 300 शब्दात लिहा वगैरे सारखं. त्याच्यामध्ये काय कंटेंट आहे, पर्पज काय आहे, कोणत्या पॉप्युलेशन साठी आहे, किती सॅम्पलवर काम केलेलं आहे, मेथड कोणती होती, आणि काय इन्स्ट्रुमेंट वापरलं, म्हणजे क्वेश्चनर वापरली, इंटरव्ह्यूज घेतले, वॉट एव्हर, अँड मेन कन्क्लुजन. एवढा पार्ट म्हणजे ज्याला अख्खा पेपर वाचता येत नाही त्याला ऍब्स्ट्रॅक्ट वाचलं तरी कळलं पाहिजे की काय आहे ह्यात. मग ज्याचा इंटरेस्ट जसा असतो त्याप्रमाणे तो अख्खा पेपर वाचेल. रिसर्च मेथडॉलॉजीच्या भागामध्ये काय लिहावं, तर रिसर्च मेथडॉलॉजीच्या भागामध्ये लिहावं की मेथड ऑफ रिसर्च, मगाशी आपण बघितलं तसं हिस्टॉरिकल आहे, डिस्क्रिप्टिव्ह आहे की एक्सपेरिमेंटल आहे, अँड जस्टिफिकेशन ऑल्सो वाय. देन स्टडी थीम्स ऑर व्हेरिएबल्स, कॅरेक्टरिस्टिक्स ऑफ पॉप्युलेशन, सॅम्पल कॅरेक्टरिस्टिक्स व्यवस्थित लिहिल्या पाहिजेत. माझा अभ्यास कोणाला लागू आहे, म्हणजे मी जर मगाशी सांगितलं एक्सपेरिमेंट मध्ये मी जर पुणे म्युनिसिपल स्कूलचा अभ्यास केला असेल तर त्याच्यामध्ये मला लिहावं लागेल की को एड स्कूल्स आहेत का, स्कूल्स फॉर बॉईज आहेत का, स्कूल्स फॉर गर्ल्स आहेत, आणि सॅम्पल मध्ये नसतील ते सॅम्पल फ्रेम मध्ये जे बसणार नाहीत ते घ्यायचे नाहीत. सो दॅट इज व्हेरी इम्पॉर्टंट. डेटा कलेक्शन कसं केलेलं आहे, डेटा अनालिसिस कसं केलेलं आहे, दॅट इज ऑल्सो रिक्वायर्ड. रिझल्ट्स अँड डिस्कशन हाही पार्ट आपल्या रिसर्च पेपर मध्ये ऍड केलेला असतो. त्यामध्ये काय डिस्कस केलेलं असतं हे तुम्ही नंतर थोडस तुमच्या इंटरनेटवरचा डेटा घालवून बघा, आणि त्याच्यामध्ये काय कंपोनेंट्स असतात ते चेक करा. पीएचडी थिसिसचं जे इंडेक्स असतं त्याच्यामध्ये आपल्याला दिसतं हे की 3 मेजर पार्ट्स असतात. प्रिलिमिनरी पेजेस, मेन बॉडी ऑफ द थिसिस आणि रेफरन्सेस अँड अपेंडायसेस. तर याच्यावरूनही कसा प्रश्न येऊ शकतो तुम्हाला कळलंच असेल आता की हा पाठ असतो किंवा हे वेगवेगळे देतील आणि हे असतात, हे 1 2 3 असतात अशा पद्धतीने, पण हे एवढे 3 गोष्टी असतात हे तुम्हाला कळलं पाहिजे. आता प्रिलिमिनरी पेजेस मध्ये डिक्लरेशन, सर्टिफिकेट, एक्नॉलेजमेंट आणि कंटेंट्स असतात. एवढ्या गोष्टी आपल्याला लक्षात ठेवाव्याच लागतील. वेगवेगळ्या लिस्ट द्यायच्या असतात, लिस्ट ऑफ टेबल्स, फिगर्स, ग्राफ्स, अब्रिव्हिएशन्स, फोटोग्राफ्स, पब्लिकेशन्स. मेन बॉडी मध्ये सोशल सायन्स मध्ये जॉन बेस्टनी सांगितल्याप्रमाणे कमीत कमी हे 5 चॅप्टर्स असतात. गरजेनुसार 6वा ऍड होऊ शकतो, पण यातला कुठला कमी नाही होऊ शकत. सो दीज आर required 5 chapters of the thesis in social science. References, वेगवेगळे स्टाईल्स आहेत रेफरन्सेस लिहिण्याचे, MLA किंवा आणखीन कुठल्या, पण सोशल सायन्स मध्ये APA स्टाईलनी रेफरन्सेस लिहिले जातात. म्हणजे अमेरिकन सायकोलॉजिकल असोसिएशनची ही स्टाईल आहे, जिची सध्या 7वी एडिशन आपल्या सोशल सायन्स मधले लोक वापरतात रेफरन्स रायटिंग साठी. मग त्याच्यामध्ये दोन्ही प्रकारचे म्हणजे रेफरन्स लिस्ट मध्ये कसे लिहायचे आणि इन टेक्स्ट रेफरन्सेस कसे लिहायचे. अपेंडायसेस मध्ये काय काय लावू शकतात त्या लावतात त्या गोष्टींची यादी दिलेली आहे. तेव्हा या गोष्टींपैकी काही कशात असतं असं विचारू शकतील. फोटोग्राफ्स, परमिशन लेटर्स, एक्सपर्टचे नावं किंवा एक्सपर्टने दिलेली पत्र, त्याच्यानंतर वेगवेगळ्या परमिशन्स, त्यानंतर तुम्ही वापरलेलं टूल आणि तुम्ही तयार केलेला प्रोग्राम किंवा असं जे काही मटेरियल असतं ते सगळं अपेंडायसेस मध्ये असतं. याशिवाय आणखीन गोष्टी आपल्याला बघाव्या लागतात रिपोर्ट रायटिंग करत असताना की या सगळ्या गोष्टी आलेल्या आहेत का. उदाहरणार्थ लिटरेचर टेक्निकचा रिलेव्हंट यूज केलेला आहे का, गुड ऑर्गनायझेशन ऑफ डेटा, स्पेलिंग मिस्टेक्स, good logic of inquiry in research, pagination, title page, dividers recent आहेत का thesis मधले, फॉन्टचा टाईप आणि साईज, आणि अर्थातच या सर्व गोष्टी वेगवेगळ्या विद्यापीठांनी आपापल्या वेबसाईटला रिक्वायरमेंट दिलेल्या असतात, त्याप्रमाणेच त्या आपल्याला करायचे असतात. लाईन स्पेसिंग वगैरे सारख्या गोष्टी. ठीक आहे. आता जो 5वा मुद्दा आहे ऍप्लिकेशन ऑफ ICT इन रिसर्च. त्यामध्ये ICTचा वेगवेगळ्या स्टेप्स ऑफ रिसर्च मध्ये कसा वापर होतो. म्हणजे फॉर एक्झाम्पल ICT कशी वापरली जाते याच्यामध्ये, कशामध्ये प्रॉब्लेम आयडेंटिफिकेशन मध्ये कशी वापरतात, डेटा कलेक्शन साठी कशी वापरतात, हाऊ ICT इज युजफुल इन डेटा अनालिसिस, आउटकम डिसिमिनेशन मध्ये कशी वापरतात, त्याचे बेनिफिट्स काय आहेत ICTच्या वापराचे, स्पीड, ॲक्युरसी, ऑर्गनायझेशन ऑफ डेटा, कन्सिस्टन्सी, various search engines, for example, in locating information, data validation, what are different tricks for quick identification, what are different types of research engines, for example, Google, Bing, Yahoo, etc. What are different websites which can be used in for research purpose. Then how ICT can be used in research dissemination, research outcome dissemination, slide share, then social media, Facebook, Twitter, LinkedIn. So these are the components which can be considered as very useful in connection with ICT in research process. And then the next and last point is research ethics. Why ethics are required, or what are ethics? तुमच्या म्हणण्याने काय ethics म्हणजे? का लागतात?
We genuine that doing the work, we should be very genuine in whatever we do. It requires some professional ethics, like maybe we can say we should not plagiarize any work.
Correct, correct. In even in day-to-day life also we need ethics, that is moral guidelines, which govern our behavior, right? Same is the case with our behavior in the field of research. We need to follow many ethical considerations and guidelines. For example, as Madam said, plagiarism, because we need to consider ethical guidelines whenever we are using somebody else's work. We should quote, we should give reference, that means due credit द्यायलाच पाहिजे. And because he or she is a original author or original researcher of that particular work. So in connection with this point, we need to learn basics about, first thing is plagiarism, then copyright, then citation, authorship, then IPR, intellectual property right म्हणजे काय, एवढं तरी बघून ठेवलं पाहिजे आपण. We need to read something about research integrity. What do you mean by research integrity? And data fabrication. What are the ill effects of data fabrication and unethical behavior in the field of research? So these its effects also to be considered by every teacher and researcher. And the last term which you should know at least something about that is acknowledgement. Acknowledgement means mm, include the name of the person who help you in your research or any kind of work. So these are the guidelines as I consider, which are very important in the preparation of Unit 2 of paper 1 given for the set syllabus. So from my side over, I think I have tried to make you aware what should be studied for this particular unit, that is research aptitude. I wish all the best to all set aspirants connected virtually as well as present over here in this classroom. Thank you once again. Thank you, college authorities, Golar sir and Anpat sir and his whole team. Thank you very much once again. All the best.
Hello everyone.
Hello everyone. It gives me an immense pleasure to propose a vote of thanks. I would like to thank our guest speaker, Dr. Megha Uplani, who honored this session with her inspirational speech on research aptitude. It was a great pleasure to listen to your wise words and tricks for solving the question paper. We are extremely grateful to you for advising us on the subject of research aptitude in your presentation and creating awareness about the same. I would like to thank on behalf of our principal, Dr. Golar, HOD, Dr. Anpad, and all teaching and non-teaching staff members. Thank you once again. Next session will be start within 3 to 5 minutes. First of all, I welcome Dr. Wafare sir on behalf of MMCC team members. Welcome, sir. Stop करो. Enter window. Second one is research aptitude. PPT research. Second, na? Workshop. First of all, I welcome Dr. Wafare sir. I would like to request Professor Sonali madam to introduce our guest speaker, Dr. Wafare sir.
Thank you, Pranita ma'am. In mathematics, the art of proposing a question must be held on higher value than solving it. Ladies and gentlemen, we begin with our second session, Mathematical Reasoning and Aptitude. I take this opportunity to introduce a resource person and intellectual in field of mathematics, Dr. Wafare. Sir is doctorate in lattice theory from Savitribai Phule, Pune University. He earns to his credit several awards and honors. To name the few, IMS Prize for Best Research Paper, Hirnandani Prize, Lokmanya Tilak Prize. He is a life member of Indian Science Congress, ISC, Indian Mathematical Society, IMS, reviewer of mathematical reviews of AMS. His area of interest in research are algebra, graph theory, metroid theory, lattice theory. Sir has guided 11 PhD and 3 MPhil students. A big applause for our today's guest, Dr. Wafare. I request our HOD, Dr. Anpat sir, to felicitate our today's guest, Dr. Wafare. We welcome you, sir. Thank you, sir. I request our guest to guide us.
हो 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 हो. असेल का? अच्छा. थोडं थोडं मागे घ्या ना असं. असं इकडे घ्या ना, मला तिकडे जा. इकडे घ्या असं. हा. Yes. हा, बस बस बस. हा. Okay. So hello everyone. I have a great pleasure to visit Marathwada Mitra Mandal's college. It is a long story that I visited this college long back, and at that time, means maybe around say 2007 or something like that. In that period, I have visited this particular college on the occasion of giving lectures or on the occasion of working as a member of LIC committee and so on. Particularly, I have a great affection with Professor uh, uh, Bhaskar Rao Jadhav, no? Bhausaheb Jadhav, sir, and we are very close friends of each other. So, because of this thing, I have a great yes. So, am I audible? Yeah. Okay. Okay. So, uh, so because of that, after a long period, I got the opportunity to visit this particular college. So because of that, I have a great pleasure, and I have also great pleasure to visit to talk with you directly after a long gap. After say 2 3 years, it was very difficult to talk with you personally, directly. So even those who are present here, and this will be a direct collaboration with you I can talk with you. You can ask the questions in between and so on. So this kind of collaboration will go on because in between 2 3 years we used to teach online. Okay? Only one person is talking, and no one is in front of you. So in fact, that is also one kind of experience. But there is some kind of difficulty that you cannot observe the faces of the students and so on. And whatever there may be difficulties. Yes. Am I audible? Yes. Yeah. Okay. So uh, so now in this situation, because my whole life, you may say that it went while teaching to the students directly and going very close to the student and ask the questions, and we just I'm asking the questions to the students, and students are also trying to reply to those questions, and with the help of this direct communication, it gives us somewhat idea how to teach to the students. Okay, how to teach, what exactly to be told, how to explain. So these things can be one can think about this and explain the things in somewhat better way. So this is another reason why today I'm so much happy to talk with you after 2 3 years. I got this kind of opportunity, and yeah, so that is the thing. And secondly, lastly, I would like to thank the authorities of this college, the principal and the HOD, Anpar and all the organizers of this uh, workshop. So I'm very much really thankful to them. It's my great honor to remain present here to deliver a talk to talk with you. Thank you very much. Yeah, so today what I'm going to talk about is some kind of mathematics. Okay, so this is now the thing that every time what happens is that uh, whenever we say about mathematics, we are becoming serious, isn't it? That's a Rekha? Huh? Yeah. Huh? असं कॉलर मध्ये अडकव. Okay. So I am going to talk about while making the full screen. Make the full screen, and only one page on one thing, so that it will be visible. Uh, yeah. Okay. No, no.
Close this and open only the PDF.
Control L. Control L. Yeah. So what I was telling you about the mathematics. Whenever we talk about mathematics, we are becoming somewhat serious. Okay. Now my today's target is don't become. My today's target is to tell you that don't become serious. And just like you are playing with something like a game, you are playing with playing some game, something like that you treat it. And that is the only way to accept mathematics, okay, and to play with mathematics, to enjoy mathematics. See, nowadays, whether any kind of competitive exam it may be there, हे सगळे सगळे स्टुडंट आहेत का काय? Volunteers आहेत का? अच्छा, okay. Okay, doesn't matter. Means whether the students are there or anything, but try to give the attention. Okay, that's important because depending upon your responses, I will talk. Okay, so that is very much important. So yeah. So as far as mathematics is concerned, today just I will try to convince you. I will try to convince you that mathematics is important, no doubt about it, or any competitive examination for that matter. Mathematics is important. Understanding of mathematics is important, and therefore, instead of just mugging something, if you try to understand little bit, okay, then it will help you to tackle certain problems in mathematics. Okay, so mathematical reasoning and mathematical aptitude is the important thing. So try to grasp the mathematical aptitude in you. So what are the basic things about mathematics that which you can try to adopt, that I'm going to tell you with the help of some examples. Okay, so some of the things which generally we can have in mathematics is the regarding the reasoning. Many types of reasonings are there. We are coming to some conclusions. Okay, see, for example, you have certain kind of property. One property is there. Okay, and then that kind of property you would like to say that, oh, that property is enjoyed by everyone. And how to prove this? Suppose some property is there and that property is enjoyed by everyone. Okay, so what you can do to every person, you can give some nomenclature: first person, second person, third person. See, mathematics starts from here. You can enumerate them. Okay, and once you have enumerated, then to prove that that property is enjoyed by everyone, what one can do? One can see that firstly just prove that, oh, that property is satisfied by the first person. Huh? Otherwise, what you have to, if you try to do it physically, oh, that is satisfied by first person, the second person, the third person, and so on. Oh, there may be many crores of persons are there, and then it will become very difficult to tell. And sometimes there may be infinitely many persons. We are just talking about persons, but in some situations you may have to talk about the infinite set. Okay, and there you wanted to say that, oh, everyone is enjoying that property. Huh? And to play with infinitely many objects is a difficult job. Okay, but then there is some mathematical reasoning is there, which will tell you that you need not have to worry. There, with the help of some calculations, you can prove that a particular property is satisfied by everyone, whether it is a finite set or it is infinite set, whatever it may be the situation. Okay, yes. Now this is a very much needed, and this is a technique which one can adopt. Okay, and for this technique, some tools are there. Those tools we are going to see. Okay, the first tool in that is the mathematical induction. Now, what is mathematical induction? Mathematical induction says that let us, whatever these objects are there, maybe infinitely many, and but in our mind you keep that those are countably many. Okay, just like natural numbers, 1, 2, 3, and so on. Okay, So you have these countably many objects are there, and you can give the nomenclature to them. Okay, so table nomenclature, first, second, third, and so on. Okay, that is decided. Okay, once that is done, then firstly prove that the first object satisfies the given property. Prove it actually. Okay, then then the second thing is that assume that, arbitrarily assume that the kth object satisfies the property. Kth object, maybe it may be 10 arbitrarily. K is arbitrary. Once you know that, once you assume that kth object satisfies the property, and if you can somehow prove that k plus 1th object also satisfies the property, oh, that is you are success, you got the success in that. What will be the conclusion? Oh, if that is the conclusion, then we have proved that the first object satisfies the property, and if this satisfies the objective because of our whatever we have proved, the second object also satisfies the property. If kth object satisfies the property, then k plus 1th object also satisfies the property that we have proved. Okay, so first satisfies, that already we have proved, and because of this argument second will also satisfy, and once second satisfies the property, then the third will also satisfy the property, because 2 plus 1 is 3, right? If third satisfies, then 3 plus 1 is 4, 4 will satisfy, and so on. You can go up to, you take any object of any number, okay, that will satisfy. So very simple technique is there. We'll see some examples of this kind, and then we will proceed further. So in mathematical induction, yes, sorry, there or not? Yeah. So for example, let me come to the board and explain you something about. You take a number which is say, what this take a? थोडा मागे घे म्हणजे तुम्हाला दिसेल, सर्वांना दिसेल असं ठेवा. Okay, yeah, that's fine. Okay, very good. So you take a number, yes, say you consider this n is a natural number. Is this okay? N is a natural number. Now if you consider the expression, namely n square plus n plus 1, this expression for any number n, you consider the expression n square plus n plus 1. This expression enjoys certain property. What is it? It is, you can if n is a natural number, okay, so natural numbers are generally denoted by n. Okay, so and then consider this n square plus n plus 1. So the first thing is that a simple observation, simple observation. लाईट लावायची काय? हा, बोला की मोठ्याने. लाईट लावा. येस, अच्छा, ओके, हा, दिसतंय का आता? ओके, काय अडचण असली तर लगेच बोलायचं. हा, बोर्ड तिकडे घ्यायचा, बर इकडे घेऊ, पण मग इथं आडवं येईल, परत तिकडे हलवावं लागेल, असं होईल. हा, ठीक आहे, असू द्या. हो हो हो, अच्छा, म्हणून इकडे घेतलं का? हा, ठीक आहे, ठीक आहे, चालेल. ओके, आता दिसतंय का? दिसतंय का आता व्यवस्थित? वा वा, व्हेरी गुड, व्हेरी गुड. घ्या, बसून घ्या. येस येस. Acha, okay. So you can think of this n square plus n plus 1, this expression. Okay, and as far as this expression is concerned, you can imagine, as far as parity of this number, this will be some number, no? For every n, this will be some number. What can you say about its parity? Means whether it will be even number or odd number. Can you say? Or some situations it may be even, in some situations it may be odd, isn't it? So, this is the question. So you may try to think over this, that what may be the situation. You have three. Always it is even. Always it is odd. Sometimes it is odd and sometimes it is even. These are the three possibilities. So among these three possibilities, which possibility you may feel that it may be there? Yes? Huh? It may be even or it may be odd. Okay, so initially one may feel like that, but the fact is that this is always odd. This number is always odd. Okay, now we will try to prove this by mathematical induction. So my statement is that my Pn, which says that this is my statement. Pn says that this expression n square plus n plus 1 is a odd number for every n. This is my statement. Okay, and we may try to prove this, but by mathematical induction. How to prove this? Firstly, prove that it is true for the first number, namely, say n is equal to 1. Actually speaking, these are the natural numbers. So 1, 2, 3, 4, 5, and so on. Okay. And mathematical induction, you may start, if you wanted to prove it for every n, then naturally firstly you prove it for 1, and then the next step you have to prove it. Okay. But sometimes some statement may be true if you wanted to say that something is true after a certain stage. Okay, after say n is equal to 10, is true. Okay, then at n is equal to 10, firstly you prove, and then the inductive step you prove, then it will follow that after 10 everything will be enjoyed by that property will be enjoyed by every number after the 10th number. Okay, this is a simple, very simple thing. Okay, but this is the tool, mathematical induction. Okay, now just see the proof of this and try to enjoy the proof. Okay, see, firstly, is this true for n is equal to 1? Yes, this number is 3. It is odd number. Job is over. It was proved. Right? Now, assume that this is true for some k. Let us, k may be anything. Okay? So, you may think of k square plus k plus 1. Assume that this is odd. Okay? Suppose this is odd. Let us assume this. Suppose. Okay, this is the inductive step. Assume that for some k, it is odd. Okay, so this number is odd number, and now we'll prove that. So pk is true. Pk is true, and then try to prove that. Prove what is to be proved? Next number, pk plus 1. Statement pk plus 1 is also true. Prove pk plus 1 is true. So this you wanted to prove it. Pk plus 1 is true. Okay, fine. So now what will be the pk plus 1? What will be the expression for that? Expression will be k plus 1 square plus k plus 1. Replace k by k plus 1. Very simple thing, isn't it? So this will be the expression, and this expression we wanted to prove that it is also odd. It's odd number. Okay, assuming that this is odd, try to prove that this is odd. Okay, so you just expand this, k plus 1 square. What is it? It is nothing but k square plus 2k plus 1. Okay, and uh, plus k plus 2. This is 1 plus 1, that is 2, isn't it? So how it will look like? It is what you can say. Yeah, I will take this. Yeah, so it's very simple now. Can you imagine what may be the situation? Just see, look at this expression which we got. Okay, I know that this is odd. Okay, so among this, k square is there. Okay, k is there, 1 is there. Take them together. That number is odd. And what is the remaining number? Remaining number is nothing but 2k plus 2. This is the remaining number. And 2k plus 2 is always even. Isn't it? 2k plus 2 is always even. And this remaining part, this number, I'm just, yeah, double line. This is odd. So odd number plus even number is always odd. Is this okay? And the proof is over. So we have proved that. Yes, yes. Huh? Huh? Okay, okay. So, so we have proved that this number is always odd, and this follows by mathematical induction. Okay, within few seconds we can prove this. Okay, but actually this we have proved for all infinitely many numbers. This expression is odd number. So that is the achievement. That is the technique, and that we get with the help of mathematical induction. Okay. So to this mathematical induction, there is also one equivalent criteria. Okay, that is known as the pigeonhole principle. Okay. So we will come towards that. Now you take this to this side. Let me just go on the board. कुठे क्लिक करायचं? Yes. Yeah. So yeah, so we were talking about as far as the mathematical induction, mathematical reasoning is concerned, several types of reasonings are there. Among that, one of them is inductive. Okay, and then you have analogy, and then the abductive, deductive reasoning, and so on. Other things are there, but few of them I'm just going to explain you. So the one of the equivalent criteria to this is the well ordering principle. Okay, just try to understand the मी असं इकडे तिकडे फिरलं तर दिसते का तिथे? Okay, okay, fine. So this is well ordering principle. What is well ordering principle? It's very easy to understand and easy to digest also. Very simple. What it says, well ordering principle says that every non-empty subset S of the positive integers has a least element. म्हणजे काय? What is the meaning of this? Positive integer means natural numbers. Okay. Among the natural numbers, you select some of them. You take a subset of that. Maybe finite, maybe infinite, doesn't matter. To that subset, well ordering principle says that it has smallest element. For the whole set, whether the smallest element is there for the set of natural numbers, whether the smallest element is there, hai ki nahi? Yes, yes. Set of natural numbers, smallest element आहे की नाही? तुम्ही आहे की नाही? नॅचरल नंबर माहिती ना? नैसर्गिक संख्या 1 2 3 आणि सो त्यातला स्मॉलेस्ट आहे की त्याला स्मॉलेस्ट आहे का? छोटात छोटा कोणता आहे? कोणता आहे? हा, झिरो नाही ना त्याच्या ह्याच्यामध्ये, 1 आहे की नाही? अगदी सोपी गोष्ट आहे. सो if we consider the set of natural whole set, the whole set has smallest element, namely 1. Now you take any subset of it. Huh? Any subset of it. Whether the smallest element will be there. Huh? Yes. Smallest element will be there. Okay. And that you can observe. You may feel that yes, it will be there. Okay. And this is but natural. And this is just like the mathematical induction. Okay. Once you have proved, you got the steps of mathematical induction, then you can come to the conclusion. You can come to some certain conclusion. Okay. So that is the mathematical induction. And here you have the well ordering principle. Very simple thing. If you take any subset of the set of natural numbers, it has smallest element. See, for example, let us play with this. Okay. So for example, if you take even natural numbers, what is the smallest number? 2 is the smallest, isn't it? Suppose you take any subset, no? So from after 10, if you select any odd number after 10, 11 is the smallest. So in this way, you can think that every subset of the set of natural numbers has smallest element. Yes. Okay. But keep in mind that this is the property which is enjoyed by the natural numbers, and it may not be enjoyed by other integers. No, it may not be enjoyed by integers. It may not be enjoyed by positive real numbers. You think of positive real numbers. Okay. So the ideas will be clear. This property may not be enjoyed by positive real numbers. Why? Can you tell me some subset that which has no smallest element of positive real numbers? Huh? Yes. Do you have a smallest positive real number? Or you may think about zero. You include zero. Okay. Include zero also. Okay. And zero to infinity. All real numbers or rational numbers you take. Okay. Whether there is a smallest element. For the whole set, yes. Zero is the smallest element. Right. But there are some subsets for which there is no smallest element. What is that? Positive. So think of positive real numbers. Do you have uh, just yeah, okay. So yeah, um, what I was telling you, yeah, positive real number means open zero, don't take zero, and then go to, and then you will find that there is no smallest element. Smallest element is the number which is to be there in that set. That is called smallest element. Okay. So to that set there is no smallest element. Okay. So that is the so try to understand this thing. However, here in case of natural numbers, the thing is very nice that you take any subset, any non-empty subset you take, it has smallest element. Yes. Okay. And that is known as the well ordering principle. Okay. And this well ordering principle is also yeah. So which way you can see that it doesn't contain, means why this is true, because if you take a decreasing sequence, are you familiar with sequence? Okay. Sequence, you select a sequence, means sequence of even numbers or odd numbers, isn't it? Okay. If you take any subset and if you take a decreasing sequence of that, okay, decreasing sequence, then that decreasing sequence must terminate. You won't get infinite decreasing sequence for any subset of natural numbers. That's the thing. Okay. So uh, because of that, this thing is true. Now, this is equivalent to yeah. So this is equivalent to the well ordering principle, means mathematical induction or well ordering principle. This statement, which we have just now proved for by mathematical induction, this you can also prove by well ordering principle. Okay, this you can prove by well ordering principle. Again, the idea is very simple. Just see how we can use well ordering principle to prove this statement n square plus n plus 1 is odd. Okay, yeah, just see the reasoning is important. How one can prove this by well ordering principle. Oh. Suppose this is not true for some n. This is by contradiction. Huh? Suppose this statement is not true for some natural numbers. Means what? N square plus n plus 1 is say is even for some natural numbers. Some set of natural numbers. Means that set of natural numbers is a non-empty subset of natural numbers. That is what we are assuming. Once it is non-empty, it must have smallest element. Say the k will be the smallest element, isn't it? So before k, okay, and before k will be the smallest element, and this k cannot be 1 because for 1 we know that it is odd number. So k cannot be 1. K is strictly greater than 1. So k is strictly greater than 1. And that is the smallest element for that k, that number is even. But once that is even for k, then you will already we did some kind of expression like this here. No? So now for k it is even. Let us assume this. For k, this is say even. Okay, this is even, and this k is smallest. Okay, and k is strictly greater than 1. What can you say about k minus 1? K minus 1 will be smaller than that. And if we put if we consider this minus now here instead of plus, you consider minus, then the expression which you will get is nothing but here you will get minus, here you will get plus, and what is that? Here the 1 will get cancelled, and here you will get 0. Do you understand this? What is the conclusion? The conclusion is that, oh, if this is even, means this k square plus k plus 1, this is even, and what is added in that? Minus 2k is added in that. Minus 2k is always even, isn't it? And k square plus k plus 1, we are assuming that it is even. Conclusion is that for k minus 1 also, if k is in our set, yes, for which it is even, and that is smallest. And for k minus 1 also, we have proved that it is even. It is a contradiction to our assumption that k is smallest, for which it is even. Because for k minus 1 also, then it becomes even. That's a contradiction. So by well ordering principle also, we can prove that this statement is true. There are many other statements of this type, okay, which you can prove with the help of well ordering principle, or sometimes you may also make use of mathematical induction. Fine. So yeah, so this is the mathematical induction which I have explained you just now, and these two things are equivalent. Well ordering principle holds if and only if. Okay, so that way mathematical induction is assumption, basic assumption, and well ordering principle is also that way assumption. See, in mathematics we cannot do everything. Okay, But once we assume the mathematical induction, then it follows that the well ordering principle can be proved. Okay. And if you assume well ordering principle, then you can prove the well mathematical induction. So this statement theorem says that well ordering principle holds if and only if the principle of mathematical induction holds. Okay, and a proof is given. Okay, so you may go through the proof if you want, but now I gave you the technique, the idea how to prove with the help of mathematical induction, how to prove with the help of well ordering principle. Okay, so these things are clear, and this equivalence also the proof is given, but we will proceed further. If you get some time, then you just go through the proof and see, you can enjoy the proof. Okay, fine. Now, yeah, so this is the proof of that. Now there is one more technique. This is the known as the pigeonhole principle. Okay, very standard. Okay, and very interesting, and one can really enjoy these things. Okay, and you can obviously you will to your heart if you ask the question, oh, whether this will be possible. So yes, certainly it will pass. Just like the well ordering principle, you will feel that yes, it must be true. Just like mathematical induction, once mathematical induction, with the help of mathematical induction, if you prove those steps, then you will find that everything will be, that property will be enjoyed by every object, isn't it? Okay, so many such type of certain things are there, basic fundamental things are there in mathematics, with the help of which you can come, that technique you can use and you can prove many things. Fine. So now you think of this well ordering principle. What is that? Yeah, pigeonhole principle. What is pigeonhole principle? Pigeonhole principle says that, pigeonhole principle. Yeah, pigeonhole means yeah, pigeonholes are there and certain pigeons are there. Okay. So suppose that there are two holes are there and you have three pigeons, then you can come to some conclusion. These three pigeons, you among these three pigeons, you will get there are only two holes are there, no? So one hole will be there which will contain two pigeons. That must be the situation. You understand? Obvious thing, no? So in general, if k plus 1 objects are there or pigeons are there and which are to be distributed among k pigeon holes, or you may say boxes, right? Then if k plus 1 objects are there and k boxes are there, then at least one pigeon hole contains two or more pigeons. Is that the obvious thing? Isn't it? Because you have less number of boxes and more objects are there. So at least one box must contain more than two or more objects. Okay, it's a very simple thing. Okay, this you can generalize. Just see the see the next thing. Yeah, this is the generalized thing. Okay, so this you can immediately prove it. Okay, and yeah, now you can just think of this generalized pigeonhole principle. Just try to generalize this. Okay, this reasoning is also very important. Okay. First one just for k plus 1 objects and k boxes. Instead of that, you may have k boxes and n objects are there. Okay, and then ask the question in general what happens. What will be the general situation? The general situation is that if you have k boxes are there and n objects are there. Okay, so you have k. Say for example, three boxes are there. We will take one example. Okay, 3 boxes are there, and 10 objects are there. Okay, then you do whatever distribution as you like, arbitrarily, your choice, freedom. Okay, you just distribute, and then the conclusion is that there is at least one box, huh, which will contain at least how many objects? At least three. No, no, this is not. This this is true, but this statement is true. At least three, but more sharper conclusion is there. At least no, at least one is true, but more sharper. It's just it's saying that at least one, that is not important. But what is, if you are saying at least two are there, that will be more important. If you someone is saying at least three are there, oh, that will be more important, isn't it? So which statement is better? Huh? At least three boxes are there, 10 objects are there. At least one is there. Oh, no doubt about it. At least two is also there. At least three is also there. At, no, three. No, huh? No, that is okay. At least the meaning of at least is that. Okay, at least three. Once I'm saying at least three means three or more. Okay, but yeah. So what is that? At least three is there. Okay, but I wanted to say something more than that. That is true. At least, yeah. Suppose, okay, let me make it more, somewhat simpler. Can I say that at least four? There is a box which contains at least 4 objects. Can we say this? Because just now see the reasoning. Yeah. Suppose this is not true. No one contains four objects. Then what will happen? Everyone will contain less than or equal to 3. Less equal to 3. First one will contain less equal to 3. Second one will contain less equal to 3. Third one will contain less equal to 3. And then the total will be less equal to 9. But we have 10 objects, isn't it? So it must be the situation that there is a box which contains at least 4 elements, and this is the number. So what in general you do? N objects are there, k boxes are there, divide by k to n. N may be divisible by k, may not be divisible by k. Okay, so it may be some fractional part. So here in our situation, it is 10 divided by 3, and 10 divided by 3. What is that fractional part? It is 3.3 something, isn't it? It is larger than 3. And what is the next integer? Next integer to that fraction is 4. So this is the notation for that. Okay, ceiling of n by k. Okay, so this is the you just consider the n by k, this ratio you consider, and in this ratio, what is just next integer that you look at. Okay, and then you can come to the conclusion that at least those many objects are there in at least one box. Okay, so this is the pigeonhole principle. Okay, very interesting thing. Okay, and it's popularly known as pigeon. Someone who got that conclusion is with the help of pigeons, and therefore it is the situation. Now this you can prove with the help of pigeonhole principle. You can prove many interesting things. One of the very interesting thing is the following. Okay, that is in terms of yeah. So we will come to towards that. will make use of the pigeonhole principle, but some few more techniques and ideas, okay, you may enjoy. Okay, and one of them you may be familiar with. You wanted to add first 100 numbers, 1 plus 2 plus 3 plus 4 plus dot 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 up to 100. Huh? Now how to do this? प्रत्येक वेळेस मिळवत राहायचं का? 1 plus 2 is 3, 3 plus 3 is 6, then 6 plus 4 is 10, and so on. But then it will take a lot of time. That's the only thing. You can do that. And if you are finitely many, then you can do it, but it will take a lot of time. You can save this time, these hours together. Addition of first 1000 numbers. You may take few hours, but that you can solve within few seconds, isn't it? Okay, if you get some technique to do it in few seconds, then this technique will save your hours of your life, isn't it? And that's the mathematics. Okay, mathematics is helpful for this purpose only. Okay, now just say that this we know. Yeah, this is the formula for first n. N may be anything. First n natural numbers, addition of first n natural numbers. This you may have studied in your 4th standard. In schools you may have studied this formula. The formula is n into n plus 1 divided by 2. Okay, so addition of first 100 numbers. What is it? 100 into 101 divided by 2. So it is 50 into 101. Okay, you will get something 50-50. That number you will get. Immediately you can calculate. No? So this helps. This formula will help you immediately to find the sum of first n natural numbers. Okay, what is the proof of that? See, means the result is important and interesting, and the proof is also equally beautiful. Okay, so you cannot imagine this is the brilliantness how to prove this. Okay, someone needs to come to this conclusion. Someone make prove this. Okay, but to prove that, what kind of reasoning is to be applied, that one can think over this. Okay, so this is just the you may try to put it in the. You can make use of a tabular form. Okay, tabular form you can make use. 1, 2, 3 up to n. You put it in a row, and you put one more row you'd select. Yes, so it will you will get a matrix of the type 2 by n. So 2 rows are there. And the second, what do you do? Second row, instead of saying 1, 2, 3 from left to right, you say 1, 2, 3 from right to left. Same thing, only in the reverse direction. Very interesting thing to see, right? So the same numbers you have repeated, but in the reverse direction, and you have this is tabulated in this form. Okay, you have tabulated it, and then see. So this you have repeated, no, 2 times. Every number is repeated 2 times, no. So the total sum will be 2 times the sum of the first row, because the sum of the first row is same as the sum of the second row, isn't it? And the total sum will be 2 times the sum of the first row. Okay, and now in this tabular form, you now instead of adding a row wise, you add column wise. What is the sum of the first column? N plus 1. Sum of the second column? N plus 1, and so on. Every column sum is n plus 1. How many columns are there? N columns are there. So the total sum of these 2 rows will be n the times n plus 1. And since n into n plus 1, that is the total sum of the two rows. So the sum of the first row will be divided by 2. Proof is over. Okay? Very interesting proof. And it is the beautiful proof. Okay. So we proved that such type of formula is available with you, and then one may need to go proceed further and wanted to do something more. Okay, so instead of getting the sum of the first natural numbers, I wanted to have the sum of after 101 plus 102 plus 103 and so on. And then you may want to stop at a certain stage. Okay, you wanted to go up to 2n. Okay, and that's sum. So in between sum that you wanted to calculate. Okay, and for that also, you see, for example, you may start at any n plus 1 step, and you may go up to n. Okay, let us make it somewhat simple situation. So starting from n plus 1, go up to n plus n and see what is the sum. And just see here. Here you will find that here in this summation, everywhere in every bracket n is there. Separate all those n together. Okay. And then the remaining sum is nothing but the sum of the first n natural numbers. This sum is nothing but n times m, that is nothing but n square, and this sum already we have proved that it is n into n plus 1 divided by 2, and therefore we got the formula for that also. Okay, so once you know somewhat the basic thing, one formula you know, then you can make use of that formula and you can jump further. Okay, so this is the development which you can do in mathematics. You can obtain many such type of formulas, achieve such type of formulas, think mathematically. Okay, and so very simple. Okay, simple to think and simple to do the calculations also, achieve the formulas also. Okay, and develop the technology. So development of technology, either this technology you may develop either in mathematics, okay, or in other areas also, whatsoever it may be. Okay, there also you can develop such type of technique and uh, proceed further. Fine. So now we can come towards our earlier thing that yeah, you can make use of what is that pigeonhole principle. Okay, very popular. Okay, pigeonhole principle. And in this, you can make use of this pigeonhole principle, and you can achieve somewhat non-trivial looking things. Yes. For example, just see the situation. Okay, what is the situation? The arbitrarily you think. Suppose that you have a party of 6 persons is there. It's going on somewhere here or there. Okay, party of 6 persons. And in this party, whether they may be mutually known to each other or may not be known to each other. Okay, so the several groups are there. Okay, with the help of those groups, the party can be arranged. Do you understand this? So arbitrary party is there of 6 persons, 6 or more. Okay, but let us just now, for the convenience, think about only 6 persons are there. Okay, and now what is the conclusion? Now I have some conclusion. In that party, there must be 3 persons who know each other, or there are 3 persons who do not know each other. Do you understand this statement? You take arbitrary party of 6 persons and come to the conclusion that there are 3 persons who know each other. They are friends who know each other. Okay. Or if that is not the situation, then there must be 3 persons who do not know each other. They are unknowns to each other. This is the conclusion. Okay. And this is a very basic and very basic result. And then further generalizations and are there, many more results are there. But that's those are yeah, those one can think over this. Okay, but this is very natural thing which, but this is not obvious. This initially, if I say like this, oh, then why this is, and why are taking six only? Why? What about five? If you take five party of five persons, okay, and then what happens, and so on. Okay. Uh, yeah. So for this, what you can do is yeah. So yeah. समजते ना? हा? कोणाला काही शंका असेल तर विचारत चला. समजलो हे मला बरं वाटेल. सर इकडे या ना. हा? हा. किंवा इथे या. आपल्याला काय ह्या वेळेस जरा चान्स मिळाला ना पोरांबरोबर डिस्कस करायचं. बरं 3 वर्ष झाले अडकून पडलं होतं सगळं. So fine. So now we have this. So all of you understand this kind of conclusion that yeah, we have arbitrary party of 6 persons. Okay, and in this then I have one conclusion. The conclusion is that whatsoever it may be the party, there are 3 persons known to each other, or there are 3 persons who do not know each other. Okay, so what we can do, we can, these 6 persons we will just represent by 1 2 3 up to 6, and diagrammatically we will represent them by some small circles. Okay, here these 3. Is this okay? So these 6 persons are there. Okay, and now if what is happening? टिश्यू पेपर होता ना. So if these are the 6 persons, then among these 6 persons, now if we take 2 persons, if they know each other, then what we will do, we will draw the line which will be a blue line. Okay, then we will draw a line which will be blue line. So blue line will indicate that they know each other. Okay, we'll put a line among the 2 circles if the corresponding 2 persons know each other. Is this okay? And we will put a red line if the corresponding 2 persons do not know each other. Okay, so for example, these 2. Okay, all of you understand this? Fine. So this red line indicates that they do not know each other, right? And now see how this problem you can convert in somewhat different language. See, given any 2 circles, there will be a line. Either it will be a blue line or it will be a red line. Is that okay? Among any 2 circles, there will be a line. That line will be either blue or red. Is that okay? Now you will find that from any circle, how many lines are going on? Huh? No, here there are 6. So let us think about 6 only. How many lines will go out? How many lines will be adjacent to one circle? 5 lines will be there, because to each one of them you will get a line. 5 lines are there. Okay. Among these 5 lines, some lines are red and some lines are blue. Is this okay? There are 2 choices. 2 boxes are there, either blue or red. These 2 boxes are there. And how many objects are there? 5 objects are there. You select one circle. You just select one circle. Say for example, any circle you can select. But say for example, this circle you select. From that circle, 5 lines are adjacent to that circle. Among these 5 lines, 5 objects are there. Among these 5 lines, some of them are blue and some of them are red. And because of pigeonhole principle, yes, what will be the conclusion? Because of pigeonhole principle,
No color can exceed three.
huh?
No color can exceed three.
No. You think as 2 boxes. One is red box, other is blue box. 2 boxes are there, 5 objects are there. These 5 lines, some of them are red and some of them are blue. By pigeonhole principle, what is the conclusion? Huh? Yes. At least 3 must be there, which are either red or blue. There is a box which will contain at least 3 objects. So there is, among these 5 lines, there are 3 lines which are red, or there are 3 lines which are blue. समझ लग सर्वन रहे? Yes. Right? So now, and what is required to prove? What is required to prove? We wanted to prove that there are 3 persons who know each other. Okay. Or there are 3 persons who do not know each other. Means if we will get 3 persons here and corresponding 3 lines will be there, no? To join into each other. So you will get 3 lines that will form a triangle. Okay. So here, if you consider the whole picture, in this picture, many triangles will be there. Selecting any 3 circles, you will get a triangle. Isn't it? Many triangles are there, and what is our claim? Our claim is that at least one triangle is of same color. There is a monochromatic triangle. Okay, either blue triangle is there or red triangle is there. Okay, and that now we are going to prove. Okay, there are 3 persons known to each other, or there are 3 persons do not know each other. So either there is a blue triangle or there is a red triangle. That is what we wanted to prove. Right? Now, what we will prove? So as we have seen just now that so because of pigeonhole principle, okay, so there are three red lines from this, or there are 3 blue lines without loss. हे समजते हैं का? म्हणजे काय होईल बरं का? If we assume that there are 3 red lines, we will prove that there is a this kind of triangle is there. Monochromatic triangle is there. Okay, triangle of same color is there. And similarly, you can prove that if we take three blue lines, then also monochromatic triangle is there. So let us assume that there are three blue lines. Okay, similarly you can prove for red lines also. Okay, so let us what is here, yeah. So this is these three blue lines are there because of pigeonhole principle. Of course you can take this line maybe from here to here, that doesn't matter, but for the conveniency we have taken these three lines. Is this okay? So don't worry about that. Now these three blue lines are there. Yes. Now you have here, forget about these two circles, only think about this part. Think about this. Four. Among these three lines are there, and some more lines are missing. We do not know what are those. Right? Here you have one line, here you have one line, and here you have one line. Three lines are now missing as far as these four persons are concerned. Okay, among these three lines, if any one of them is blue, we got the answer. Samajhte? If among these three, if either this is blue, or this is blue, or this is blue, if any one of them is blue, our job is over. Samajhte ka? If not means what? If not means what? None of them is blue. म्हणजे काय? Every one of them is red. Then also job is over. Isn't it? Because in that situation, this will be the red, this will be red, and this will be red. We got red triangle. Okay. So in that situation also, our job is over. And similarly, if we assume that three red lines are there, then also by the same argument, you will get a monochromatic triangle. And that proves the result. So this is very interesting result which says that give any party of six persons, six or more. Can you generalize this? Six or more. Because among if more persons are there, among them you can select any six of them, and among that you will get this kind of result that there are three persons who know each other, or there are three persons who do not know each other. Okay, very simple thing. Okay, so in any party of more than six persons, you have this conclusion. But what about less number of persons? 5 persons. If you have 5 persons, can we come to the same conclusion? Yeah. So you may have, yeah. So probably, yeah, I may have drawn the diagram. Yes. Yeah. You just where is that? Yeah, so here we have seen the proof of this, and now this is the diagram which we were thinking of. Now come towards the 5 persons. Okay, if you consider a party of 5 persons, then this result is not true. For example, you consider these 5 persons. Okay, and this is the situation. Red means unknown to each other, and blue means known to each other. Okay, so this will you will find that no triangle is there. You take any three vertices, no triangle is monochromatic triangle if this is the situation. Okay, so there are no 3 persons known to each other, and there are no 3 persons who are unknown to each other. Okay, so for 5 it is not true, for 6 it is true. Okay, and now this is for your interest. Okay. Oh, this 6 has something to do with monochromatic triangle. Okay. So, are three persons known to each other. Now you may ask the question, oh, I want a situation in which if some party is there, there are at least four persons known to each other, or there are at least four persons who do not know each other. Okay, and then where to start? For three, we have to start with six. Okay, for four, from where we have to start? For five, from where we have to start, and so on. Okay, very, and this is very rich theory is there. This is known as the Ramsey, and these numbers are this six number is the Ramsey number. Okay, for three. Okay, and for others also some numbers you will get, and that theory is there. But very interesting theory, and it is useful theory. Because of that, you can come to certain conclusions, and those results you will get. Fine. Now you will also come towards some fixed point theorems. In mathematics, there are certain theorems are there, and who are popular, very popular and very interesting. Okay, see, see what are those? One of them is known as this Brouwer's fixed point theorem. Okay, so what the Brouwer's fixed point theorem says, yeah, suppose this was the sheet, no, this was the sheet, and which was suppose it was the which was kept initially, it was from here, and it was, we have taken it out, and then I have just crumpled it, and I have kept it here on that. Okay, this is something which has happened. Okay, some father is there, okay, who is a teacher, doing some calculations on a table, okay, on a particular sheet, and then his son or daughter is coming, okay, and what is written, it is what it was dirty thing, so he is taking away that sheet, and then crumpling it and keeping it over there. Just like this, I did it here. Okay, now what is the conclusion? A very it's not obvious thing. Okay, initially whatever the situation was there, every point on this sheet you can associate with a point which on the sheet which is just below that. Every point there is a 1 1 and onto correspondence between the points on this sheet and the points on this sheet. Okay, some correspondence was there. Okay, and after that I tried to do this and kept it here. Okay, and now I'm asking the question, oh, everything got disturbed, no? Initially the association was there, the point, and just above to that. Okay, and now this is what it happened, and now one may say that everything is disturbed. What the fixed point theorem says, no, you cannot disturb everything. At least one point is there of this page which is just above the point in which was there earlier. समझते you cannot disturb everything. Only thing is that you have to keep this crumpled sheet above this, and now you can have the association of any point just below that, any point just below that. That's like a projection. Okay, earlier association was there, now also you can give the association, and in this situation many points are coming together and going on the same point. Okay, what is the conclusion? The conclusion is that there is at least one point on this page which is just above the earlier one. So at least one point is getting fixed. You can't do everything. Okay, you do whatever you do anytime. You put it here, you put it here, you put it here. Anything arbitrarily you do, and doesn't matter. Okay, that's the Brouwer's fixed point here. Okay, as far as it's not obvious. Okay, In fact, this can be explained in somewhat different way. Okay, you have a cup of tea, or you have here you have some water is there. Okay, in this bottle, right? Now the every particle of this water. Okay, so whenever you are keeping it here, then you can have some three-dimensional thing. Okay, and you can associate every point. You can actually locate every particle's position. Okay, it's x coordinate, y coordinate, z coordinate. Okay, giving the this thing. So you can, or simply in the simple language, you say that here this bottle is kept it here, and now you just see the situation of every particle, observe it carefully. Okay, and you can look at it carefully, and then you just pick it up and you steer it. That coffee, you steer it. Okay, and again put it at the same place. Okay, or if you have cup and coffee is there, you steer it. Don't move here and there. You just steer it. Then the particles will move here and there. Okay, and then after some time, if everything is settled down, then come to the conclusion. Ask the question whether everything is disturbed. Brouwer's fixed point theorem says no. There is at least one particle which was there where it was earlier. Okay, so this is the power of mathematics. You cannot disturb everything. It's impossible to disturb everything. Okay, of course, in this situation. Okay, so this is the Brouwer's fixed point theorem, and because of such type of theorems, then yeah, this is the person who is the Brouwer, and he proved this the fixed point theorem, and then by making use of this theorem, okay, this theory has been developed further. Okay, and then many mathematicians, these are mathematicians, and got Nobel Prize in economics by making use of such type of fixed point theorems. Okay, just like our earlier result. Okay, any party, arbitrary party of 6 persons, you have some certain conclusion. There are 3 persons known to each other, or 3 persons that do not know each other. Monochromatic triangle must be there. Okay, so similarly here in this situation, we have such type of result is there. This is the Brouwer's fixed point theorem, and with the help of which you can develop the theory, and that you can apply in economics or in other areas also, and you will get many important results. How much important? You will get a Nobel Prize. Okay, so this is the situation. Fine. Now, this is in somewhat three-dimensional situation. Okay, three-dimensional situation, right? Now we will. I will not go towards the board, but I will just try to explain these things orally. Okay. So what you do? This is three-dimensional thing, Brouwer's fixed point theorem, but you can also think of two-dimensional. Means plane. Three-dimensional means three-dimensional. Okay, so this you may treat a cup of the coffee, you may treat it as an object in three-dimension. Okay, and in a plane you can think of a certain diagram in a plane. Okay, that you can think of this. Okay, and then what you can do? See, you can draw one triangle. Okay, in two dimension you can draw one triangle, 3 vertices, and triangle is there, and those 3 vertices you give the nomenclature to that triangle. You give the nomenclature. Means sometimes you give the nomenclature A, B, C, isn't it? Sometimes you may give the nomenclature 1, 2, 3. Okay, let us give the nomenclature to the vertices of that triangle. Say 1, 2, 3. Okay, and now once you have a big triangle is there, that triangle you can further divide into subparts, and so many baby triangles you will get. Do you understand this? One triangle is there, okay, and that triangle you can further, you can do something further so that and that you do arbitrarily, no? So very interesting thing, okay. So yeah, don't disturb the thing, everything you just once you have certain kind of triangle is there, then you can have further triangles, you can have, yeah. So this you can have. Do you understand? You will get baby triangles, okay, and you can do this further arbitrarily, you can proceed further, and you can have more triangles here. If you like this, then you will get more triangles, okay. So okay, so many triangles you will get. Do you understand this? Original triangle, the nomenclature was say given say 1 2 3, and now some you can form the original triangle, you can subdivide it into baby triangles and again give the nomenclature. Huh? नाव द्यायला काय जाते? Huh? To each triangle you have to give some nomenclature, okay, and that nomenclature you give with the help of these three numbers 1 2 3 only. Okay, so if some new vertex is coming into the picture, it's now your choice to give. Here you say 2 1 2, arbitrarily these numbers you just put it there, only you just follow one restriction. See, this is 1 3 line is there, and if here something is coming into the picture, some vertex is coming on this line, then don't give the nomenclature. uh, uh, Here what is written to this, don't give 2, is that okay? 1 2 side by either 1 or 2, label the vertices on the side 1 2 side by either 1 or 2. Yeah, so here 1 and 3 is there, so don't give the nomenclature 2 to this, either 1 or 3. Here 2 3 is there, to this vertex either give the nomenclature 2 or 3. Okay, similarly here either give the nomenclature 1 or 2, don't give 3 here, don't give 2 here, and don't give, that is the only restriction. In between vertices, you, that is your choice. Okay, no restriction at all. Here also there is no restriction, small restriction is there on the adjacent thing. Okay, now if this is the situation, then what this is known as the Sperner's lemma. What it says, then arbitrary nomenclature you have given to the vertices, then you can come. So yeah, some triangles may be like 1 1 1, some triangles may be 2 2 2, some triangles may be 1 2 2. Okay, but what is there? Means many the many nomenclatures will be there. Original nomenclature was 1 2 3. Can we get a baby triangle whose nomenclature is also 1 2 3? And see, nomenclature was arbitrary that way. Okay, so some small restrictions were there. Okay, Sperner's lemma says yes, there must be. You arbitrarily give the nomenclature. Okay, with this small restriction, there must be a baby triangle whose nomenclature is also 1 2 3. Okay, this is the Sperner's lemma. Okay, and yeah, this is the two-dimensional aspect of Brouwer's fixed point theorem. Okay, you can also do one-dimensional aspect of that, and that you can imagine. Okay, that is very much important. One dimensional on the line. Okay, so suppose now the situation is the following. Okay, see, I have yeah, so I'm just playing one game. Okay, with the help of this game, I'm trying to explain you one dimensional fixed point theorem. What is it? See, you have a certain काय प्रश्न आहेत नाही ते? Yeah. So every time I'm here now on one step, then next step I will put it on the next Hershey. Is that okay? and arbitrarily I will go ahead, and sometimes I will go back. Okay, so I will get the forward steps I will take, or I will take the backward steps arbitrarily. Do you understand this situation? Then some conclusion you have. If you have taken some forward steps, and then you have taken some backward steps, okay, and you are in between, you may have sometimes forward, sometimes backward, but ultimately if you are coming back to the situation, then you have one conclusion. In between situation is completely arbitrary, okay, in this game. And only the thing is that your whatever your initial stage was there and your final stage is there, it is the same. What is the conclusion?
Some total of forward and backward steps
Yes.
has got cancelled, so that we are at the original forward.
Yes. So what is the let us ask this question. You are right. Your thinking is right. So only the thing is that you think of number of steps which you have taken. Maybe forward, maybe backward. The total number of steps, if you are again at the original position, initially I was here, and again I am at the original position, and now ask the question, the total number of steps which you have taken must be. Yes.
Say, forward steps
Yeah. That is, yeah. That's right. That's right. But I'm asking total number of steps. You are right. Means the one conclusion is that the number of forward steps which you have taken must be equal to number of backward steps. That's right. And it is equivalent to say that the total number of steps which you have taken must be. काय? Total. आता forward backward विसरून जा. The total number of steps which you have taken must be. Yes. काय? Yeah, you are right. You are right. Double means what? What is that number? What can you say? What is the property of that number? Huh? Even number. N plus n, not n into n, but it will be n plus n. Okay, so it will be an even number. This is the one dimensional this thing. Okay, and in this yeah, so our time is, I think, over. So I will just conclude with this thing, and then we will stop. See, these are the 6-point theorems, and very simple. If you wanted to do it practically, either you do it via this, or do it in other way, or you can have such type of thing. You have, say, for example, 1 to 15 numbers are there. Okay, and then you can have a mapping from these numbers 1 to 15 to 1 to 15. Mapping from 1 to 15 to 1 to 15. May not be 1 1, may not be on 2. Many points may come together. Okay, so this set to itself, you have a mapping which is arbitrary mapping. Only the property is that this mapping preserves the order. समजते का हे? Order preserving म्हणजे काय? See, here there is order. 1 is less equal to 2 is less equal 3 is less equal, and so on. So this is order is there. Maintain the order. See, for example, 2 is less equal 3. Then the image of 2, that is f of 2. Image of 3, that is f of 3. What should be the relationship between f of 2 and f of 3? Don't switch. F of 2 must be less than or equal to f of 3. That is called order preserving mapping. So any order preserving mapping from this set to itself, you take whatsoever it may be. You may put any them together. Okay, move here and there. Arbitrary. This mapping may be arbitrary from that set to itself. Okay, just like we did it here. Okay, so you did it crumbling, or you can steer the coffee, or do anything. Okay, arbitrary. Similarly here, arbitrary order preserving mapping you consider, then this you can observe. Okay, you can prove it, and you can observe, you can enjoy it. you will find that at least 1 point will get fixed under that map. Okay? Definitely 1 point must get fit. You cannot shuffle everything. That is the conclusion. With this, I hope that I try to convince you how helpful is mathematics, what kind of reasoning is there in mathematics, and how to get the aptitude as far as the mathematics is concerned, and how it is useful. Okay, many conclusions you can have. It will be really very much helpful, and in many areas it is helpful. Okay, so there are many more things to tell you, but maybe next time or other time I will explain those things. With this, I will thank you for your patience and hearing. Thank you. Oh,
Omkar, Omkar, share this. It gives me an immense pleasure to propose vote of thanks. I would like to thank our guest speaker, Dr. Wafare sir, who honored this session with his inspirational speech on mathematical reasoning and aptitude. It was a great pleasure to listen to your wise words and tricks for solving multiple theorems with live example. Are extremely grateful to you for advising us on the subject of mathematical reasoning and aptitude in your presentation and creating awareness about the same. I would like to thank on behalf of our principal, Dr. Gollar, HOD, Dr. Anpad, and all staff members. Thank you once again, sir. We will take a break for the lunch. The next session on people development and environment awareness comprehension. We will start after half an hour. Thank you, sir.